So, welcome to the next part in Workbook 3, Atoms and Elements. So, understanding the relationship between atoms, elements, their properties, and light is very important for understanding modern astronomy. So what is an atom? Let's start there. So, ordinary matter is made up of atoms. Atoms are the smallest unit of matter which can't be broken down by chemical means. So ordinary chemical reactions. It doesn't mean that atoms can't be broken down. It just means that they can't be broken because they can be broken down by nuclear means, which we're going to cover a lot later on in this course, so the different nuclear means for breaking down atoms. But atoms are the smallest unit of matter that can't be broken down further they're basically the simpler way of thinking of an atom is is the building block of all ordinary matter. And that's why you can never believe an atom. They make everything up. Ho ho! Was that funny? I hope it was. People were like, oh my gosh, Dr. E, that is the dumbest pun. You should take my geology course. Lots more puns there. So there's 3 subatomic particles in an atom. You probably know what they are. If you're saying to yourself, proton, neutron, and electron, then you are correct. So protons are positively charged. Neutrons are neutral, and electrons are negative. So protons and neutrons live in this part of the atom known as the nucleus. Whereas electrons travel around the outside in shells. Or we could also say clouds. And they're not real, you can't really say like they're exactly there. It's a probability thing. It gets very complicated, way beyond anything we need for this course. But basically, electrons are outside the nucleus, protons and neutrons are inside this nucleus. So we can label this as protons, and this we'll call this neutrons. And we'll have this be electrons. So this is where our electrons are. These little dots right here. And then protons are in here. And neutrons are also in here. You don't have to necessarily make these little coloring ins, but once again, doing a little coloring like that on this particular diagram can help. So, what is an element? An element is the simplest form of matter. Matter being a very fancy word meaning stuff. Okay, so for example, the universe is made of matter and energy. Matter is stuff. Energy is the ability to do stuff. So when you say that the universe is made of matter and energy, what you're literally saying is it's made out of stuff, and stuff can do stuff. And that's what we mean by the universe. So the simplest form of matter, in other words, stuff, it cannot be broken down further. By chemical means. And you might be like, well, then how is it different than an atom? An atom is a chunk, is a piece. That's the smallest piece. Whereas the element is the stuff. So elements are all listed somewhere. You got it. This is in the periodic table. So the periodic table contains all known elements. And another important idea is that elements, atoms of an element all have the same number of protons. Not necessarily neutrons. We'll talk about that in just a few minutes, but they have the same number of protons, and they'll be important when we're talking about the periodic table. So here, let's flip the page and take a look. This right here is the periodic table, the table of all of the things. So everything in the known universe is made of some combination of these little building blocks, atoms of each of these types. Okay, so these are basically types or flavors of atoms. Well, you could say species of atoms, but that might get confusing if you're like really good at chemistry, because the chemical species is a thing. But these are the different types of atoms out there. So let's take a look at one of these. We're going to take a look at helium over here. We're going to take a look at this little box, and we're going to break it down. Okay. So you're going to see that in this little box for helium, in the periodic table, it's got a couple of numbers. It's got a two, in symbols. It's got a 2. It's got He. It's got 4.003. And then it has, at the very last, at the bottom, helium. That's each one of these things. And I kind of color-coded it just a little bit to break it down a little better. So this right here is the atomic number. And this is equal to the number of protons. So that means that helium has how many protons? Right, it has 2 protons. This right here is the atomic symbol. And that's just the chemical shorthand for the name of the element. This is the average atomic mass. We're going to go back to atomic mass in a few moments when we talk about isotopes. But the atomic mass is measured in atomic mass units. And then finally, helium, right here, this is the name. Not all periodic tables have the name of the element listed in there, but this periodic table that I chose here does. So this one here is actually from your textbook, and you can find that in the either in the appendix or in, I think you can find it in chapter 5, possibly. Yes, maybe. Apparently not. So you cannot find it in chapter 5. But it's a useful thing to try to understand a little bit about the list of the elements and what elements, what this actually means, because we're going to start talking, when we start talking about the life cycle of the star, we're going to be talking about the elements that the star made. Because one of the things you're going to learn is the only elements that we had in the Big Bang was lots of this and a little of that. All the rest of this came from the life cycle of a star. So let's keep going. An isotope. An isotope is a group of atoms that all have the same number of protons and neutrons. And neutrons. So all atoms in each element can be grouped into isotopes. Now, isotopes and elements are really hard to understand until you actually look at an example. So let's go ahead and do that right here. I'm going to grab a nice straight edge. Once again, you don't have to get a straight edge. I just think it's kind of useful. So, and I'm going to switch to a black pen so it's easier to see. I'm going to leave a little space up here so I can list things at the top of the table. Okay. And this black pen is not cooperating as well as it could, but that's okay. That's okay. We're not seeking perfection here. We're just seeking good enough. And I think this is good enough for right now. So let's go ahead and fill in this table. So over here on the top here, I'm going to list this as our element. Here I'm going to have these isotopes. Over here, I'm going to have the number protons. Here I'm going to have the number neutrons. And over here in this last column over here, I'm going to have the atomic mass. And we're going to start with the example of carbon. I'm going to start with carbon. Carbon, its symbol is C, has 3 common isotopes. Carbon 12, which is 12C. Carbon 13, which can be written this way. And carbon 14, which can be written this way. So notice that here I have this number over here, okay? And I've put that number over here. So to connect these two numbers together, I'm just going to take my pink pen. I'm going to circle it. I'm going to say, okay, those two are the same. These two are the same. These two are the same. Now, how many protons do each of these isotopes have? Take a moment and think about it. What element are they? Right, the element is carbon. So carbon always has 6 protons. So all of these have the same number of protons. I'm going to go ahead, I'm going to say that, use a slightly different color to make it stand out and say 6 protons for each one of these. And it'll become clear in just a second why I'm doing that. I'm going to grab one more colored pen over here to make it a little bit clearer. Now, my number of neutrons, however, is different for each of these carbons. So the way that we end up with the number of neutrons, the number of neutrons is equal to the atomic mass minus the number of protons. Okay, if that's real fast, it'll make a lot more sense when I put the numbers in here. So this number up here is the atomic mass. I'm just going to stick my finger over here. We're going to leave a little space over here. And so my atomic mass here is 12. My atomic mass here is 13. My atomic mass here is 14. So pink to pink, that's making that connection over there. So the atomic mass is equal to the number of protons plus the number of neutrons. I'm just going to use green for neutrons, and that will equal my atomic mass. So to get the number of neutrons, I just have to say 6 plus what equals 12? Good. 6. 6 plus 7 equals 13, and 6 plus 8 equals 14. So the number of neutrons is 6, 7, 8. So this number here at the end of the isotope name, or up here in the isotope symbol, comes from the atomic mass. The atomic mass is the sum of the protons and the neutrons. Now this is a lot of information right here. If you need a little bit of extra help, don't be afraid to reach out. Some people are like, well, I took chemistry, I'm an old hat at this. And some people are like, I'm an accountant. Why would I take chemistry? So wherever you are, that's okay. So if you need a little extra help with this, don't be afraid. So quick discussion right here. The symbol with a 4 up top and an He represents helium with an atomic mass number of 4 and is the most common form of helium, containing 2 protons and 2 neutrons. What does the symbol 3He represent? So first of all, is 4He an element or an isotope? If you think that this is an isotope, you're right, because it has a number attached to it. So this little number, this little 4 right here, is important. So this is an isotope. And does anybody remember what that number represents? That's the atomic mass. Excellent. So that number represents the atomic mass. So what does this symbol right here represent? Well, now we have a 3. So this is helium isotope with an atomic mass of 3. Now it's helium. How many protons does helium have? So helium, well, I would get that from back here in my periodic table. And we saw that over here, right? The number of protons on helium is 2 because that's its atomic number. So helium has 2 protons. So the isotope, helium-3, which can also be written 3He. Those are the same thing. This is just the symbol. That's the name. Has 1 neutron. And the reason for that is 2 protons plus 1 neutron equals the atomic mass. And we're just going to label each one of these. 2 protons plus 1 neutron equals the atomic mass. Make sense? Don't be afraid to email me if it doesn't. Now the very last thing is getting the idea of electrons. So electrons can change energy level. They can bounce up and down basically in energy level. And that's important because this pattern of energy level is inherent to the type of element that you're looking at. So it also determines what the energy is that the electron will gain and release. Now there's rules attached to this. It's a little bit like puzzle pieces. An electron, this electron, for example, cannot accept 5 eV. This one cannot accept 11. It has to be exactly 10.2. So there are these rules based on the type of element that you're looking at that say, okay, only this energy level is accepted. Another and easier way to think about it is like these are different energy levels, and these different energy levels are like keys, and only certain keys fit inside these energy levels. Only certain types of photons fit inside those energy levels. So it's got to be just the right size to fit there. Now, when we get over here and start talking about spectra, we'll get a little bit more in depth in that concept, and that's in the next video.